Hi, let's look at some regular polygons vis-a-vis circles and see how we can relate them.
But sir, what is a regular polygon?
Regular polygons are polygons where the sides are equal and also the included angles are equal. Now, let's see if we can fit the polygons inside the circle one by one. Now, all the polygons are inside the red circle. Do we see anything interesting here?
Yes sir, I can see that the red color is gradually reducing.
Good observation. But what does it mean?
Don't know sir.
The pictures are telling us that as the number of sides of the polygons keep on increasing, the polygon actually approaches the shape of a circle.
Oh yes, that's cool. But sir, why did you skip the pentagon?
Yes, I don't want to mess with them, if you know what I mean.
Ha ha ha, poor joke. I think you just forgot to add.
Hmm, you just caught me. Anyway, now let's look at why regular polygons, and for that matter, circles, are called similar shapes. Let's look at it from the perspective of circles. We can see that the smaller circle and the bigger circle can share the same center, and the smaller circle can be easily scaled up to approach the shape of the bigger circle, and the bigger circle can be easily scaled down to approach the shape of the smaller circle.
Okay sir, but what is the result of this similarity?
The result is that the ratio of the circumference and diameter of all circles are constant, and that constant is called pi.
And what is the value of this pi sir?
Well, to find the value of pi, you'll have to cut the circle, straighten it up like a string, and measure the length using a ruler, and then divide that length by the length of the diameter. It is an irrational number of value approximately 3.14. Now, how do we compute the area of a circle? We know the basic definition of area is width multiplied by height.
But sir, the circle is round. There is no width or height.
Correct. So let's do one thing then. Let's cut the circle into very fine, thin pieces of concentric circles. And let's do one more trick. Let's cut the circle into two equal pieces across the center and separate them out. Take the semicircular segment on the right, separate out each of the coils, straighten them, and then stack on the ground besides each other. The length of the largest coil will be equal to half of the circumference, which is pi r, and the smallest coil will be close to zero or tending to zero.
That's nice. So we now have a right angle triangle on the right. I know sir what to do next. I will do exactly the same with the left semicircle, and this time, I will hang them upside down, so that I get an inverted right angle triangle.
That's awesome. Now let's slide the two triangles towards each other, stack them together, and get your rectangle.
Bingo! Now we can apply our known formula of width multiplied by height to find area. Thank you sir, it was quite interesting.